Hi everyone, welcome to Data and Innovation Summit 2020. I thank organizers for having me here as well. This is third of my attendance in this conference, but this time it's remote. So speaking from my home, recorded, so I'll miss the interaction, I'll miss the gestures and questions in person. But let's try to maximize what we want to do today. So I'm talking about AI and ML for smart solutions for airport. And I'll take you through a couple of examples that I have put together. We may not have a lot of time, but let's see how best we can see how infusion of AI and ML can speed up your go-to-market strategy or bring your data more live and speedy. So brief about me and the organization. So due to COVID impact, we had 95% less revenue, and a lot of leadership team executives have been restructured and are not with the organization now, and I'm one of them. So the organization is the UK's busiest airport. Since I'm not there now, I'm trying to not take the names. And I was a member of senior leadership team working very closely with the group CTO. And I delivered some key initiatives around innovation in data using cloud, using artificial intelligence and machine learning. Group, meaning the airport has businesses around retail, real estate, parking, rail, and so on. Moving on, so this is something what we would try to cover. So we look at airport analytics overview. Then we look at a typical messaging day at the airport of this size and this traffic. And then we'll see that IoT and analytics is cloud bound already. If you're not, then you're perhaps a few years behind the curve. And we'll see a typical implementation and then problems with it. And then we'll see problems with traditional IoT and analytics. And then we'll see how the AI and ML infusion gives it some kinetic energy. So being in data space, analytics is my core. And these are the areas I looked after from an analytics point of view for the airport to improve operational planning. So to do that, we had to increase telemetry of processes. We had to evaluate some process bottlenecks and some overheads and the cost of it. Create data heat maps for process and wherever there are problems. So that helped improve operational planning. Also for constant ongoing performance monitoring, because the airport is all about keeping lights on. So performance monitoring, data insight for future planning and evaluation of the plan execution, how well we have done, how better we have done, and how well we can do in future. And then the airport's capability statement. So every now and then, this airport is capable of 100 million passengers a year, or this airport is capable of moving 10 million bags a day or so. So that performance monitoring, reducing wait time. So it's one of the key objectives of the CEO was to reduce wait time. So reduce wait time of passengers as well as bags and overall check-in, check-out flow. So one of the aspects of that was predicting airport in-out flow. Now, the current model was all very descriptive, that these many flights, you know these many passengers, and then the advanced passenger information gives you this much traffic of passengers in a flight, and then accordingly you know what is there. But based on the patterns and existence, we had trained some models, machine learning models, to predict in outflow in based on seasonality and times and flights and the destinations to and fro. And also part of reducing wait time was um, improving time it takes to go from curb to gate, and accordingly overall it's leads to improved customer experience. Better customer experience, in other words, is also improved staff morale. So if we have all these in place, that's how well we are doing from an operational planning, how well we are doing from a performance monitoring and reducing weight. This also leads to measurable KPIs for staff. So there are no subjective evaluations and you know human touch or human error touch to the staff reviews, reducing employee stress. So efficient operations means less stress and improved morale. Also means improved customer experience. So a happy employee gives you a better customer experience. When you have measurable goals, obviously better security, lots of false positive alarms that go at the airport, and it can delay overall check-in check-out process. So reducing false positive alarms and giving them meaning, tagging them with reasons and tagging them with more payload of data, and improved signaling across the airfield and equipments and infrastructure, and then based on that continuous training. Obviously, baggage is a big part of performance monitoring. So three key objectives is to basically improve baggage performance. So managing inbound, outbound luggage, reducing something called dye bags and chokes while baggage moves, and then sort out it efficiently based on the type of passenger or based on the type of service. So the economy or premium or first, and then sorting them out efficiently. Overall, all these leading to improved customer satisfaction. So that was basically airport analytics put into practice for improved operations. Moving on, so what we are seeing now is a typical messaging day at the airport. I'll just put all of them together for your ease of quickly glancing over them while I speak. So we get typically 1 or 2 million messages per day for flights, just alone flights. So which is like schedules, estimated, expected, gate open, gate close, and boarding, and taxied, and return to stand, and so on. Passenger messages, 5 to 8 million messages per day, which are like, boarded and boarding and returning to terminal and check-in, check-out at the gate, and so on. As we go on, the size and number of messages increase. So we're talking about baggage messages, which are anything between 15, 17 million to 19 million messages per day. The baggage messages are, actually bag generates messages. So baggage messages about transfer and remove and reflight and terminating and identification, screening, delivery, and so on. Missed and reloaded and any manual problems. So these various kinds of messages, every bag can generate all of these messages or many of these messages. So 17 million messages per day. Then we go on to service messages. So there are even more. Service messages typically 24 million to 27 million per day. Service messages mean something is at check-ins, people are self-checking in, people are at the gate and boarded. So this about, they're not only about passengers and flights, but they are about service. And then the big chunk is about equipment messages, or we can say infrastructure messages. So infrastructure equipment messages are 65 million to 100 million per day, which are about airfield operations, baggage equipment, signals, alarms, cameras, and so on. So the messages, the type of messages are being heartbeats, alarms, status updates, and transactions at equipments. So they are 65 million to 100 million messages per day. So this is not all. So these are the main business data objects about which the messages are captured every day. And apart from the loads of loads of data, constituent of a flight and so on, which are not mentioned here anyways. But this is what moves the airports. This is what keeps it operational and inflow, and this is the active, and people are concerned about this data and so on. This needs to be on operational 24/7, although you may not see flights in the night, but these messages keep coming in. They are for not only for flights, but also outside of the flight. And hence the infrastructure for it need to be scaled up, capable of and delivering these. So now this is basic. What we are coming to is what we have done recently. We know that these messages have been part of a network that is there for quite a few decades. So network of things has always been there. And what we're talking about now is Internet of Things, which is its extension. So Internet of Things is there. So implementation of Internet of Things. Connected devices were always there for operational use. What you do now is you scale it up. Now we can locate, monitor, manage, and analyze those connected messages, and that too from cloud. Meaning we are taking all those messages that we just mentioned into cloud and in real time and analyzing them. And not only analyzing them, generating intelligence on the top of that. But to be able to do all that, there are some very basic things from an AI, ML point of view and IoT point of view. You need to add on devices to convert analog signals from digital signals. So if there is any part of the infrastructure map that is still on analog signals, you need to get them onto digital signals and add those devices. Otherwise, they're not part of the network that will move the information. So once they are digital signals, information then can be moved onto the network. So once it's on network, it's agile, it's speedy, it's moving. And then we add the business transformation capabilities on top of that, which is remote access and then predictive maintenance of everything on and so on. So that becomes your artificially intelligence enriched information network. So few basic things, So data generated by these connected machines then needs to be transformed into something that adds intelligence. So transformation is a key part in there. So what happens in projects is what we're seeing now is a typical implementation of data problems or projects or programs. So you have you have a queuing layer, then you have a lake layer, and then you have an orchestration layer and warehouse layer and then access layer. So data passes through all these layers, and then finally it's available to the end users and in access layer. And then obviously, if you do this, you might do it via various technologies. So you have a plethora of technologies to do this. So for example, you may use Kafka service buses to queue the messages, and you may have raw curated aggregated data lakes, storing messages and making them available. Orchestration layer could be Spark, Glue, Data Factory, Polybase based. I'm not talking about old ways of moving data to ETL and so on, but this is even in the new world, this will be your implementation. You have a warehouse level, you stage, transform, and keep it ready for production. And then you have typical dashboards and reports and alerts and notifications on top of that in your access layer. So that's a very traditional implementation of a data project like that. And what are the problems with typical IoT analytics problems like this is that there is inherent loss of early data availability. So you go through these layers and then data is not available as soon as you want. As I mentioned, the beginning time to market is less and time to access is also less. You have longer and many months, many years duration projects, and then it kills the viability of those projects. You have loss of speed of to react to those intelligent information, and then obviously you have such a long program which would add to your cost overheads with typical IoT analytics projects like that. I'm just checking the time and where we are. So what I have done closely working with the metrics team here is that picked a few examples to implement the changes in terms of how data is used. So a couple of examples are, we want to know the unknowns of the unknowns. For example, blind spots for drones, so entire airports infrastructure, facilities, signals, map, and then available for analysis. Automatic side wind, headwind, speed and flight speed patterns and their analysis. Till then, these were all manual, skill-based, simulation-driven, and then subject to human, we can say, skills. However, AI-driven adjustment to flight paths and human power on airfield. These were two important changes. So what I'm saying is that AI-driven workforce automation for the human power on airfield. Key changes. Another example, which is for machine learning, is that is around baggage. So, for example, a bag, if it is 1 hour late, it causes 180 pounds for the airport and airlines together to make it available to the passenger. A risk model for bags for a passenger, which could be late. It was written in R. Machine learning trained over 1.5 years of data, that model, and then something called a bag risk ML model was delivered, which had lowered late bags from 37,000 to 29,000 a year, and still counting and still delivering. So some basic couple of examples on how these could improve airport operations. One simple example of putting some kinetic energy into these solutions is serverless computing for fast tracking your IoT analytics projects. So, for example, equipment alarms, which I mentioned before, satellite tower communication, airfield radio messages, and so on, then the machine's heartbeat and movement messages. Bring them into data lake, filter the noise in data, that is, take out what is not needed. From a raw data lake, apply machine learning, create intelligence, have a curated data lake, and then use something called a Power BI. So we have a unanimously single cloud house. So we use Power BI. So a lot of Power BI dashboards or directly over data lake to give access to raw and curated data. So this is a very simple example of serverless computing to quickly generate some analytics on the fly. And then again, a little bit more detail on that part is, so there's streaming. So use event hubs or IoT hubs, use stream analytics to push data to the storage layer and then semantic layer, and then something called push data sets we used to make it available directly for visualization and reporting. So all the calculation aggregations were done in push data sets using using stream analysis functions. So the data that goes to storage in this process is further used. So this top layer process, which is about making the IoT data available, is 30-second end to end. That means the point the message leaves the source to the point it is visualized, not only raw, but in a calculated and intelligent way, is 30 seconds in this solution. And that's over the number of messages we talked about. So the data that is made available in storage is subject to further models. So real-time AI-driven decision support and decision making. And also the data intelligence that is generated over in the data lake is used for data chains-based automated workflows, which was we were talking about workflow, human power at airport. So I'm cautiously avoiding manpower to be more gender diverse, to say human power. And then raw data access through blob stores and so on. So this was a big cost saver. No expensive database servers, there was no expensive compute, there was less and reduced data movement, and there was reduced software footprint. So licensing reduced, vendor lock-in reduced, and then it was a 3-month MVP and 6 months for the first product to go live. So in a very short span of time, an analytics project implemented. So I think that's a quick rundown of a few examples and how we did it. Session for you all. I welcome any questions. Not sure how we do while in the session or later on. But you're welcome to ask any questions, and we'll try to answer by the means the organizers would provide. Thanks a lot.